everyone, welcome back to our YouTube channel. I'm Desire, and today we've got Lucky who has completed the course ROS2 Navigation, and you'll be giving us a presentation about that. So, first of all, we'll see a demonstration of his presentation on the Rio robot, and then we'll get into the details about how he managed to do his project. And towards the end, we'll get to ask him a couple of questions like we normally do. So, I'll now give him the floor so that he can begin his presentation. All right, Lucky, whenever you're ready.
All right. Thank you very much. Okay, so I'll just give my brief introduction. I'm Lucky Prajjwal Shrestha, and I'm currently pursuing my master's degree in electrical engineering from University of Houston. And today I'm here to show the roster navigation project.
Mm-hmm.
All right. Let me quickly show you the demo first. So I'm currently opening the ROS. I
Mm-hmm.
have already saved a config file for ROS,
Okay.
which I'm going to load now with the path runner. All right, so this is the configuration that I've saved.
Mm-hmm.
All right. So as you can see, there is no map right here
All right.
for now, as we have not launched anything here. And also, I have already created a map beforehand so that it will be easier for us to work in here.
Okay. How did you create it? Using simulation or the real?
And I created it using Real Robot.
Okay. It's it's very brave and very nice. I like that.
Yeah, I mean, the environment we're changing every time I use it in the real robot, but I think as the obstacles are very small,
Mm-hmm.
uh, they don't matter that much.
Yeah. Normally, your local path plan is supposed to handle avoiding those obstacles. So I like that approach quite well. Very much. It's better
Yeah.
to work with the real environment.
Let's launch our uh, localization server, which also includes map server node. So localization that launch. All right, we can see the map here.
Mm-hmm.
So this is the map that I created the other day when I
Mm-hmm.
was using the robot.
Mm-hmm.
As you can see, the map is not perfect.
All right.
Let me get a proper view for this map.
Try shift drag.
Yeah, I'm doing that, but
It's not moving.
uh, yeah, I'm doing exactly shift drag. What?
Maybe it's just a little bit slow.
What is happening? All right, never mind. Let's just keep it this way.
Okay, it's fine.
In this map, the as you can see, this block is this.
Mm-hmm.
There was one obstacle here. There was two obstacle right here and one here, as you
Okay.
can see.
All right.
Right, and one is here, I guess. All right. And as I launched the navigation node, this
Mm-hmm.
also has a map server node, as I told you.
Mm-hmm.
This also has the localization node. I can localize the robot right here.
Mm-hmm.
So let's just localize the robot at first. For the localization of robot, we just use 2D pose estimate right here
Mm-hmm.
in the arrays. And we can see the robot is in around this area, its position, and the orientation is it's turning in this direction,
Yes.
which is towards the block,
Yes.
and is right to the block. So around this, right here. So we're gonna localize the robot now in this direction, approximately.
All right.
All right. So the map is not exactly proportionate to the laser scan data that we receive here,
Uh-huh.
but we can fix that by moving the robot a little bit.
Okay.
And let's use plot planning server to move the robot.
All right.
Mm, mm,
You're using the path planning server to move the robot to localize it. Is that right?
no, I mean, I can move the robot using this as well, but I just wanted to move it using the path planning server by itself. But
Um,
as yeah, if I
you
just move it right here, it can just localize itself.
Yeah,
Pretty.
the reason I asked is you have to be sure that your map is accurate for you to now use your path planner, right? That's why I was asking.
Oh,
Yeah, but
all
if
right.
you move it using Telop, then yeah, you are in control. It's not like you're giving over control to the path planner, but it's fine. Let's see. Um,
All right. So let's quickly launch this. All right, it's launched. So for the path planning, we can use the 2D goal pose functionality in the ROS right here.
mm-hmm.
Uh, So as the robot has localized itself in the map,
Mm-hmm.
uh, we can use the path planner.
Okay. Okay.
All right. For you to use the path planner, we must have we must already have the map using map server
Mm-hmm.
and also the localization server.
Right.
So after having that, we can use the path planning server. So let's use the pathline server to move the robot. Let's move it around here, around this section. All right, as you can see, it has made the path, but I see a lot of obstacles here
Mm-hmm.
in this, so I don't think it will be able to
Yeah,
move through this way.
it must be able to avoid it.
Yeah, it says goal failed right here
Okay. Okay.
because it is
Can
failed.
can you try sending a different goal while it's still there? I just want to see if it can avoid it on second attempt.
I'm sorry.
Can you try sending a different goal while it's still there? Right. I just want to see if
All
it
right, all
can
right,
manage to avoid
sure,
it on second attempt.
sure. Let's give it here.
Okay, that's good. That's good.
Hmm. It's still not good enough, but it's still processing the new path.
All
Let's see if we do that or not. Oh, it says reach the goal.
right. Try one more time, just to see, because
Yeah,
it
yeah.
did the proper orientation. I wonder why it did move.
Let's define the orientation as well in this direction.
Okay. All right. Okay.
All right, it moved to the exact location.
Yeah, clearly there was something going on with the round
Yeah,
obstacle.
yeah, right here. Yeah,
Yes, that one.
because of that.
But yeah, at least it managed to get there, right?
Yeah, exactly. That I think that's because of the map that I created earlier. which creates certain problems because
Yeah.
in the map there is no obstacle here, but there are some obstacles.
Yeah.
But you
And
know, the obstacle avoidance is exactly for that
yeah.
purpose, right?
And what it's seeing, right, with reference to your map that you created,
Yeah.
and it's seeing
Mhm.
something cylindrical, and then on the map that thing doesn't exist. So yeah, it's
Yeah.
probably that as well.
All right, so let's give it another goal so that we're sure of that.
Hmm.
Let's give here the easy one.
Yeah.
All right, so that was successful, as you can see here. All right, so one more thing that we need to do was to save the spot
All right.
of the robot at the current location. And I did that using the another Python file
Mm-hmm.
called spots to file
All right.
right here.
Right.
This saves the current location of the robot.
Mm-hmm.
By location, I mean orientation and position.
All right.
Position and orientation of each of its location at each location, and these are the labels that I gave
Okay.
to the position.
All right.
All right. So this was also this node was also launched in the project localization node, project localization launch file
Mm-hmm.
uh, in this file together with everything right here.
All right.
So we can see that this node is already launched in here,
Mm-hmm.
right? So we can just call it. All right, let's call this kernel as kernel one.
Okay.
All right. So I as I showed you, I have three
Oh, you have them
positions right
saved.
here.
Okay.
I've already saved. If you want, I can delete them, or the after I call the node here, it can just replace the kernel one
Mm,
label right here.
let's use these ones first, and then you can use recreate them. Right. Let's use these ones first.
You want me to use this one
Yes.
for the?
Then we'll recreate the the whole process after you have used these ones for execution.
All right, I saved these positions in the previous session, but let's see if it works.
All right.
Let's see. Mm, let's see. Let's just copy this and see. And we can paste it here like this. So we send the navigation goal
Mm-hmm.
using the command line
All right.
and the save data right here.
Okay. Okay. Oh, you're not using ROS parameters. I see.
Yeah. Yeah. So as you can see, it is defined right here and it moves to the goal.
Right. Right.
And it's pretty smooth.
Right. I also noticed. Right. That's good.
As you can see here, it has finished going to the goal.
Mm-hmm.
The result is succeeded. As you can see, the position and orientation here as well
Mm-hmm.
for the goal. All right, so you want me to do the new one? I can replace them if you want.
No. Let's try going to the crossover. Right. Can you
All
send?
right,
Yeah.
let's see. Okay,
Mm,
all
okay.
right.
Let's see.
So it's going to the crossover right there. The points are exactly not aligned
Okay.
to
Okay.
what is saved and what's exactly in the map here.
All right.
But I think you did a pretty good job here.
Yeah. Yeah. Okay.
All right.
All right.
It is succeeded. Oh,
All right. That's good. You didn't. Um, did you not use the configuration file to send the sports?
oh no,
You
that I
didn't.
didn't do.
Okay, that you
Yeah,
didn't do.
I just
Okay.
send the goal from the console. Yeah.
All right. All right. Yeah, that's fine. Do you have slides that you'd wanna?
No, I don't have slides. I can go to the code here.
All right. Yeah. Let's go for that.
Okay, so all right. So here I have around five ROS2 packages.
Mm-hmm.
I have custom interface packages in which I have defined a service message service interface,
Mm-hmm.
custom interface
Mm-hmm.
right here. This is used to save the spot manually. Right here, we
Mm-hmm.
give a label as the request, which was corner one, corner two, and crossover in my case.
Mm-hmm.
And it response is going to be a message, whether it has succeeded or not. And no, the navigation successful bool. This will be true if the it has successfully saved the location, and
Mm-hmm.
this is the message that we're gonna print after the result.
Mm-hmm. Mm-hmm.
All right. This is for the custom interface. We have a map server. So this what this does is basically uh, provide the map to the other nodes
Okay.
for right for the use.
Right. Right.
So main purpose is that one.
Mm-hmm.
There's a project localization server. No, at first there's a project mapping package. What this does is to make the map initially using the cartographer node.
Okay.
We use basically cartographer to map everything. There were other tools for mapping and localization, but basically we use cartographer
Mm-hmm.
for the whole purpose. All right. So after that, we use path planning packages. No, after that, we use localizing mapping. My bad, I'm sorry.
Mm-hmm.
Localizing to localize the robot in the map, where the robot ex is exactly in the map, right?
Mm-hmm.
So
Mm-hmm.
after making a map, we should know where the robot is so that we can further proceed for more actions.
Right.
Right. So this is exactly what that is for. And within this package, we launched various node. There's a map server. All right.
Mm-hmm.
So this map server exactly does what I told you earlier. It just publishes the map to the other nodes.
Okay.
There's AMCL, Adaptive Monte Carlo Localization, which is basically responsible for the localization of the robot that we did earlier
Mm-hmm.
using the R, right? So there's a navigation to lifecycle manager. This is a node. This is an extra node that we have to use in every other package so that this node manages every other node, the state of the every other nodes,
Right.
all
Okay.
right?
Okay.
And there is a spot recorder node
Okay.
that I used for recording the spot and saving the spot in the spots.yaml file that's
Mm-hmm.
here. All right, so basically project localization package is used for all of those. And after localizing the robot, we're gonna use path planning package to plan the path and move the robot around.
Okay. Okay.
All right, so in the path planning, we have used navigation to controller, navigation to planner, behavior tree nodes,
Mm-hmm.
and the lifecycle manager,
Okay.
as always.
Okay.
As I told you earlier, for this to work, we have to have the map server and the localization or AMCL node that we use in the localization package.
Mm-hmm.
All right. So that's pretty much it, I guess. And I have pretty much saved the ROS configuration file
Mm-hmm.
here so that I don't have to manually do it every time.
Right. That's good. That's
Hmm.
highly recommended.
Hmm. Yeah. I think that's pretty much it. Yeah.
All right. Thank you for a very nice presentation. So just a couple of questions, right? So you spoke about other tools that you could have used for building the map. Can you give me an example of any one of those?
Yeah, simultaneous localization and mapping, SLAM.
Yeah, which are the slam toolboxes
Right?
can you use for that?
Uh, the mapping section of SLAM, I haven't used the SLAM, so I don't know the exact details, but I know that I can use SLAM.
Okay, all right. So you use cartographer, yeah. So the other one is the slam toolbox, like you said. Okay, so that's good.
Yeah.
That's good. And then the other question I would like to ask you is, with regards to the AMCL node, right? Can you tell me the significance or the relevance of particles? What does changing the parameter number of particles do to the way the MCL works?
The number of particles,
Yes.
you say,
So
based on the
increasing
number
them,
of particles,
yes, increasing them or decreasing them, how does that affect your localization?
localization. If we increase the number of particles in the map,
Mm-hmm.
it will it will increase the precision of our localization
All right.
because the more the particles in the map, the more precise the probability of the localization gets.
Right.
Because uh, if the particle are um, clustered in a single place
Mm-hmm.
and there are some few particles around the other places and a lot of particles in the at the place where the robot is,
Yeah.
then there's a high probability because we have more precision. I mean, we can define the robot's position more precisely because of the large number of particles that we have.
Right.
But if we have a small number of particles, then we have the what do you call it? Um, I forgot the exact word for that term.
Okay.
Well,
All right, no worries. I do get understand what you're trying to say. So, all right, on to the next question, right? So, still on the localization process, can you give me one situation that you would really that will force you to increase the number of particles, right? One navigation situation that you are highly required to increase the number of particles, even though it might affect computational time.
mm, highly recommended to use a high number of particles, right?
Yes.
Okay.
So let me give you a hint. So you do realize that every time you using you you are localizing your robot, right? There is a way you help it by sending a pose estimate, right?
Mm-hmm.
So you either give it a pose estimate using RVs, or you do it using the command line, or you do it using a YAML file, right? So in
I
this
get it.
case, you are helping your robot, right? So what is the other
Yeah.
case that
Yeah.
you?
Yeah. So in this case, we're helping, but if we have a very large number of robot, it can localize by itself without our help. So in that case, uh, the number of uh, the number of particles should be much larger than
Yeah,
what we're using right now.
yeah. Okay, all right. So it's
So
just that's where I was trying to get to. So to just straighten it up a little bit. So when you cannot help your robot localize itself, right? Ideally, it would be good
yeah.
for it
So
to increase the number of particles so that it can localize itself more accurately. So
yeah. Yeah.
it's
That
just
would be more practically feasible as well because in the
yeah,
real world scenario, we cannot like localize it by ourselves. So
yeah,
it has to localize by itself.
yeah.
So we have to have a larger number of particles, right?
Yeah, it's global localization, right? In the course, it will be it falls under global localization. It's the process where the robot would have to localize itself within the whole map, right? So it doesn't know exactly, and it has no clues from you of about where it is
Mm-hmm.
exactly. So when it needs to do global localization, we need to increase the number of particles. So you are on the right track. You are on the right track.
Yeah.
All right.
All right.
Very nice presentation, Lucky. Thank you very much. And so let's wrap it up here and just hang on for me, okay?
All right. Thank you. Thank you very much.
All right, everyone. So this was Lucky's presentation. We a warm congratulations to him and to all those who would like to give it a try. We wish you all the best, and once you're ready, you can come give your presentation here. So until